Hi, my name is Micaela Altea Garces. I am from STEM 11 Platinum and I am going to make a video presentation about the behavior of gases in general chemistry. Amount of gases. When we inflate a balloon, we are adding gas molecules. If temperature is constant, then doubling the number of particles doubles the pressure, directly related to each other. Gases naturally move from areas of high pressure to low pressure because there is empty space to move into. A spray can is example. Variables that describe a gas. The four variables and their common units: pressure in kilopascals, volume in liters, 3 temperature in Kelvin, 4 amount in moles. The amount of gas, volume, and temperature are factors that affect gas pressure.
Number 2. Volume of gas. In a smaller container, the molecules have less room to move. The particles hit the sides of the container more often. As volume decreases, pressure increases. Thus, volume and pressure are inversely related to each other. 3. Temperature of gas. Raising the temperature of a gas increases the pressure. If the volume is held constant, temperature and pressure are directly related. The molecules hit the walls harder and more frequently. Boyle's law. 1662. Gas pressure is inversely proportional to the volume when temperature is held constant. Pressure times volume equals a constant. Equation: P1 V1 equals P2 V2. T equals constant. This is graph of Boyle's law. Boyle's law says the pressure is inverse to the volume. Note that when the volume goes up, the pressure goes down. Number 2. Charles' law. 1787. The volume of a fixed mass of gas is directly proportional to the Kelvin temperature when pressure is held constant. This extrapolates to zero volume at a temperature of 0 Kelvin. V1 over T1 equals V2 over T2. T equals constant. Converting Celsius to Kelvin. Gas law problems involving temperature will always require that the temperature be in Kelvin. Kelvin equals Celsius plus 273 and Celsius equals Kelvin minus 273. Gay-Lussac's law, 1802. The pressure and Kelvin temperature of a gas are directly proportional, provided that the volume remains constant. P1 over T1 equals P2 over T2. The combined gas law. The combined gas law expresses the relationship between pressure, volume, and temperature of a fixed amount of gas. P1 V1 over T1 equals P2 V2 over T2. Ideal gases don't exist because molecules do take up space. There are attractive forces between particles, otherwise there would be no liquids formed. Dalton's law of partial pressures. For a mixture of gases in a container, P total equals P1 plus P2 plus P3 plus so on and so forth. P1 represents the partial pressure or the contribution by that gas. Dalton's law is particularly useful in calculating the pressure of gases collected over water. Diffusion describes the mixing of gases. The rate of diffusion is the rate of gas mixing. Molecules move from areas of high concentration to low concentration. Effusion. A gas escapes through tiny hole on its container. Think of a nail in your car tire. Diffusion and effusion are explained by the next gas law, Graham's law. With effusion and diffusion, the type of particle is important. Gases of lower mass diffuse and diffuse faster than gases of higher molar mass. Helium effuses and diffuses faster than nitrogen. Thus, helium escapes from a balloon quicker than many other gases. So that is my video presentation about the behavior of gases. I am Micaela Altea Garces from STEM 11 Platinum.